Hi children, in today's lesson we'll learn how to compare fractions which have the same or different denominators. We'll also show you how to sort fractions from least to greatest or from greatest to least. And finally, we'll try to understand which integer a fraction is close to. Now, let's start from the first subtitle of this video. Comparing proper and improper fractions with same denominator. Now, if two fractions denominators are equal to each other, then the fraction whose numerator is greater than the other's numerator will be the greater fraction. In the first example, as you see, the general question here is the following. Compare each pair of like fractions using these symbols. Greater than, less than, or equal to. Now, in the first example, as you see, we have two fractions whose denominators are 13 or equal to each other. These fractions numerators are also equal to each other. So these two fractions should be equal to each other. So I should write here this notation equal. In the second one, again denominators are equal to each other. But the first fraction's numerator is 9, is greater than the second fraction's numerator 4. It means 9 over 10 is greater than 4 over 10. Let's repeat again. If denominators are equal to each other for positive fractions, then the fraction whose numerator is greater than the other one's numerator will be the greater fraction. Now let's continue with the next or the third example. Denominators are 6 here, again equal to each other. The first fraction's numerator is 2, as you see, and the second fraction's numerator is 4. 2, because of being 2 less than 4, 2 over 6 should be less than 4 over 6. So I should write here less than. What about the last one? Denominators are equal to each other again. And let's compare the numerators. Because of being 11 less than 40, then 11 over 15 should be less than 14 over 15. So I should write here less than. Now let's continue with the next page and the second example. Our common question, compare each pair of like fractions using these symbols. Now, in the first example, as you see, denominators are equal to each other, namely 5. Let's compare numerators. The first fraction's numerator is 14, and the second fraction's numerator is 9. 14 is greater than 9. Because of this fact, 14 over 5 is greater than 9 over 5. So I should write here greater than. What about these two fractions? They are equal to each other. The first one 15 over 14, the second one 15 over 14 again, so they should be equal to each other. Now let's continue with the third one. Now denominators are equal to each other again. What about the numerators? Because of being 10 less than 13, 10 over 9 should be less than 13 over 9. So I should write here less than. What about the last question? And the last question, you see equal denominators. So we should compare the numerators of these fractions. Because of being 12 greater than 9, 12 over 8 should be greater than 9 over 8. So I should write here greater than. Now let's continue with the next page. I think you understand when the denominators are equal to each other, for the positive fractions, of course, this rule, we should compare the numerators of these fractions. And a fraction whose numerator is greater than the other fraction's numerator should be greater than the other fraction. Now the second subtitle here, comparing proper and improper fractions with different denominators. Now, if denominators are different but numerators are equal to each other, in like being in the first example, here denominators are different but numerators are equal. This is a bit contrast to the first type of examples. These examples, if you remember, denominators were equal to each other, but here numerators are equal to each other. Then a fraction whose denominator is greater than the other fraction's denominator should be less than the other fraction. Now here numerators are 8, and what about denominators? Let's compare the denominators. Because of being 11 greater than 9, 8 over 11 should be less than 8 over 9. I think you understand this. Because 8 over 11, what does it mean? It means you are dividing 8 with 11. 8 over 9, what does it mean again? You are dividing 8 with 9. Which one gives you the greater result? 8 over 11 or 8 over 9? Of course, 8 over 9 gives you the greater result. Now let's continue with the next. Now both denominators and numerators are different here. Then we'll apply the following rule. We should equalize denominators or numerators to each other. Choose one of them. Now here, let's equalize denominators. Now our denominators are 6 and 15. In which number we may equalize them? We know the way. We may equalize 6 and 15 in their least common multiple from our previous lessons. So let's find the least common multiple of 6 and 15. Because 6 divisible with 2, start with 2. 6 over 2 is 3. 15 is not divisible with 2. So we have 3 and 15. We may divide both two numbers with 3. 3 over 3 is 1. 15 over 3 is 5. After that, 5 is divisible with 5. 5 over 5 is 1. After getting 1s here, the result or the least common multiple of 6 and 15 will be the multiplication of these three numbers. 2 times 3 is 6. 6 times 5 is 30. So I may equalize the denominators at 30. So I should multiply with 5 for 6 both numerator and denominator of this fraction, and with 2 this fraction again the same way. 5 times 2 is 10. 5 times 6 is 30. What about the second one? 2 times 5 is 10, and 2 times 15 is 30. We got the same results. 10 over 30, 10 over 30. It means these fractions are equal to each other. So I should write here equal sign. What about the next one? Now, both numerators and denominators are different from each other for these two fractions. Now let's equalize numerators here. 6 and 3. 6 and 3 may be equalized in 6. So I should multiply this fraction with 1 and this fraction with 2 to equalize their numerators at 6. 1 times 6 over 9 is again 6 over 9. What about this one? 2 times 3 is 6 and 2 times 7 is 14. Now, what does 6 over 9 means? It means I am dividing 6 with 9. Don't forget it. And what does 6 over 14? I'm dividing 6 with 14. I'm dividing 6 with a number greater than 9. So the result will be less than 6 over 9. So it means 6 over 9 is greater than 6 over 14. So I should write here greater than sign. What about here? The last example. Numerators are equal to each other. If numerators are equal to each other, we should compare denominators. And the fraction whose denominator is greater than the other's denominator will be the smaller one. Okay. So 4 over 10 is smaller than 4 over 8. The result coming from 4 over 8 will be greater than the result coming from 4 over 10. You know from division operation these facts. Okay. Now let's continue with the next page. Which of the following is less than 3 and 3 over 8? I have 3 as whole number, and the choices again 3, 3, 3, 3. All whole parts are equal to each other, so I should compare the fraction parts. I should find the fraction which is less than the given number 3 and 3 over 8, or I should find the fraction whose fraction part is less than 3 over 8. 3 over 8. Now, what about 1 over 2? 1 over 2. Let's compare 1 over 2 with 3 over 8. I may equalize their denominators at 8 by multiplying with 4. So, it will be 3 and 4 times 1 is 4 numerator and 4 times 2 is 8. Now compare 4 over 8 and 3 over 8. I should compare them because whole parts are equal to each other. Don't consider the whole parts to solve this question. Only compare the fraction parts. Now 4 over 8 is greater than 3 over 8 because 4 is greater than 3. So it's not less than in the first choice A, the given fraction 3 and 1 over 2 is not less than 3 and 3 over 8. What about this one? I should compare 3 over 4 with 3 over 8. of course, I am dividing 3 with 4 for 3 over 4. Dividing 3 with 4. The result will be greater than the result coming from 3 over 8. So 3 and 3 over 4 is also not less than 3 and 3 over 8. So choice B cannot be the solution. What about this one? I should compare 1 over 4 with 3 over 8. Equalize denominators at 8. 3 and 2 times 1 is 2. 2 times 4 is 8. Now, as you see, I should compare 2 over 8 with 3 over 8. 2 is less than 3. I should compare numerators. 2 is less than 3. Because of this fact, 2 over 8 is less than 3 over 8. It means the given fraction in choice C, 3 and 1 over 4, is less than 3 and 3 over 8. So my solution here for this question is choice C. What about this one? Is 5 over 8 less than 3 over 8? No, it's greater than 3 over 8. So choice D cannot be solution. Now let's continue with the next question on this page. Which of the following is equal to 3 over 4? Now this is 7 over 10. It's not equal to 3 over 4. What about this one? I should change it into its improper fraction form. This is mixed fraction, you know. 1 times 4 is 4. 4 plus 1 is 5. It's 5 over 4. And 5 over 4 is not equal to 3 over 4. So choice B cannot be solution. What about this one? 3 over 4, 3 over 2. 3 over 2 is greater than 3 over 4 because we are dividing 3 with 2 less than 4. So choice C cannot be solution. What about choice D? 6 over 8. Let's simplify it by dividing both numerator and denominator with 2. If you divide 6 with 2, you will get 3. If you divide 8 with 2, you will get 4. So it's equal to 3 over 4. So choice D is the solution for this question. Now let's come to another subtitle, ordering like fractions. Like fractions, you know, fractions whose denominators are equal to each other. Arrange each set of like fractions in increasing order. You know, if denominators are equal to each other, or if the fractions are like fractions, then the fraction whose numerator is the greatest, this fraction will be the greatest fraction. So in increasing order, so I should find here the smallest one. The smallest fraction is the fraction whose numerator is the smallest. 12 over 10. Because 12 is the smallest numerator here. So 12 over 10 is less than. After that, 13 over 10. Less than. After that, 14 over 10. Less than. After that, 15 over 10. That's all. Now let's continue with the next. Now here denominators are equal to each other, 7. Which is the smallest one? Of course, the smallest one is the fraction whose numerator is the smallest. So 1 over 7 is the smallest fraction here. After that, 5 over 7. After that, 8 over 7. And after that, 9 over 7. 9 over 7 is the greatest one. What about the third question? Denominators are equal to each other, 3 here. So which is the smallest one? 4. 4 over 3. 4 over 3 is less than 5 over 3, less than 7 over 3, and less than 8 over 3. That's all. What about the last one? Denominators are equal to each other again. 12. Which is the smallest? 1 over 12. Less than. After that, after 1, 5 comes. 5 over 12. After that, 7 over 12. And after that, the last one, the biggest one, 11 over 12. That's very easy, I think. Now let's continue with the next one. Ordering unlike fractions. Of course, we should equalize their denominators or numerators. Which is the easier? Choose this. Now here, for the first question, equalizing denominators is very easy or easier than equalizing numerators of these fractions. Now, 2, 3, 5, and 6, we may equalize them at their least common multiple. So firstly, let's try to find their least common multiple. 2, 3, 5, and 6. Divide with 2, this is 1, this is 3, this is 5, this is 3. After that, divide with 3, this is again 1, 1, 5, 3 over 3 is 1. After that, 5 should be divided with 5, the result is 1. All reached 1. So multiply these three numbers. 2 times 3 is 6, 6 times 5 is 30. 30 is the least common multiple of 2, 3, 5, and 7, 6. So 2 should be multiplied with 15, 3 should be multiplied with 10, 5 should be multiplied with 6, and 6 should be multiplied with 5. Then we'll get which fractions. Let's write here. 15 times 3 is 45 over 30. 10 times 10 is 100 over 30. 4 times 6 is 24. 6 times 5 is 30. 5 times 11 is 55 over 30. As you see, we equalized denominators to each other. Now, so I should compare their numerators, which starting with the smallest. So I should find the smallest one. The smallest one is the fraction whose numerator is the smallest. 24 is the smallest here. It means 4 over 5. So right here, 4 over 5 less than is less than. The next one, 45 over 30. It's 3 over 2 less than. After that, 55 over 30. It's 11 over 6. The simplest form. 11 over 6. And the biggest one, 100 over 30. It's 10 over 3. I should write here its original form, or the simplest form given in the first question. Now let's continue with the next one. Equalizing denominators 7, 15, 6, and 10 is harder than equalizing numerators is 1, 13, 1, and 7. Now let's try to try to equalize numerators here for this question. 1, 13, 1, and 7. So I should equalize numerators here. 1, 13, 1, and 7. Divide with 7. This is 1, this is 1, this is 13, and this is 1. Divide with 13. All of them 1. So 7 times 13. 7 times 13 is the least common multiple of these four numbers. It means 7 times 13 is 91. I should equalize at 91 numerators. So I should multiply this 91, this with 7, this with 91, this with 13. So which fractions I'll get after multiplying numerators and denominators with these numbers? 91 times 1 is 91 over 7 times 91. 7 times 1 is 7. 7 times 9 is 63. What about the next one? 7 times 13, 91. 7 times 15, 105. 91 over 6 times 91. 6 times 1 is 6. 6 times 9 is 54. Last one. 7 times 13, 91. 10 times 13 is 130. Now, as you see in this question, numerators are equal to each other. So, which is the smallest one? The smallest is the fraction whose denominator is the greatest. Which one? 637. So 1 over 7 should be the least one. After that, 91 over 546. 1 over 6. After that, 91 over 130. It means 7 over 10. And the biggest one is 91 over 105. It means 13 over 15. And that's all. I think you understand why I solved this question by this method. Now let's continue with the last subtitle. Rounding improper fractions. Rounding. We should find the fraction which is nearest. We should find the integer. The given fraction is the nearest this integer. Is nearest to this integer. Now, for example, 6 and 1 over 4. 6 and 1 over 4. I should find these fractions. I should find the integer where this fraction is nearer than the other fraction. Any fraction, if it's not equal to an integer, should be between two consecutive integers. So I'll find this fractions I'll find the integer where this fraction is nearer than the other integer. For example, 6 and 1 over 4. 6 and 1 over 4 is greater than 6. So this fraction is between 6 and 7. This is 6, this is 7. Now 1 over 4 will decide about this fraction. Where this fraction closer or nearer. 6 or 7. 6 and 1 over 4. Now, you know the midpoint of this interval here, let. And it means if here is the midpoint of this interval, then it will be 6 and 1 over 2. So I should compare 1 over 4 and 1 over 2. 1 over 4 is less than 1 over 2. 1 over 4 is less than 1 over 2. So my number 6 and 1 over 4 should be between 6 and 1 over 2. So my number is closer to 6 than 7. So round each fraction to the nearest whole number. It means 6 and 1 over 4 is 6. It's not exactly 6, but it's closer to 6 than 7. And what about this second one? 2 and 5 over 7. It's greater than 2. So this number between 2 and 3. Now the midpoint of this interval will be 2 and 1 over 2. So I should compare 5 over 7 with 1 over 2. How? By equalizing denominators. 5 over 7, 1 over 2. Multiply with 7, this, and 2 with this. This with 2. And the results will be 2 times 5 is 10. 2 times 7 is 14. 7 times 1 is 7. And 7 times 2 is 14. So their denominators are equal to each other. 10 is greater than 7. So it means 10 over 14 is greater than 7 over 14. It means 5 over 7 is greater than 1 over 2. So my number given here should be between 3 and 2 and 1 over 2. So it means this number is closer to 3 than 2. So this is the meaning of rounding a fraction to the nearest whole number. What about this one? Round each fraction to the nearest whole number. The same question. So 9 over 4. Now let's change it into its mixed form. 9 over 4. In 9 we have 2, 4. And the remainder is 1 and again 4. What about 11 over 3? In 11 we have 3 times 3. 3 times 3 is 9. 11 minus 9 is 2. So the remainder is 2. And again, I should write here 3. Now, we may find the integer for these two mixed numbers, like being in the first example. Now, 2 and 1 over 4 is between 2 and 3. Here, the midpoint, 2 and 1 over 2, it means 1 over 4 is less than 1 over 2. So my number is here between 2 and 1 over 2. So my number is closer to 2 than 3. So the result here is 2. I rounded it. What about 3 and 2 over 3? This number is between 3 and 4. This is the midpoint, 3 and 1 over 2. So I should compare 1 over 2 and 2 over 3. Equalize their denominators. Multiply with 3, multiply with 2. And get 3 times 1 is 3, 3 over 6. And the other one, 2 times 2 is 4, 2 times 3 is 6. And compare them. Their denominators are equal to each other. 3 is less than 4. So 3 over 6 is less than 4 over 6, you know. It means 2 over 3 is greater than 1 over 2. So my number is between 4 and 3 and 1 over 2. My number is between them. Maybe here, for example. So 11 over 3 is closer to 4 than 3. The result is 4 here. This is the rounding. I think you understand the meaning of rounding. That's all. Now, I think we learned these 3 main subtitles for this video. And with this video, our fraction part is over. We'll continue with next subject, new subject. Hope to see you on the next lesson. Bye.